Hello, this is Paul from Foresight Tech. This lecture we're going to evaluate definite integral using integral properties. The major two properties here we are going to use. So first we're going to prove the first property. So why look at this, and this we call the addition rule. If we're going to find the area from A to B and add another area from A to C and then from C to B, and exactly merge them together, we can cancel the middle. This we call the internal, okay, the internal C, and then we cancel the C, we get it. The final is A to B. So why this is correct? Look at I show a graph, okay, so you can see the idea clearly. Like so we're going to show you here. So a little bit this graph, and if the function is supposed like this, if this is A, this is a B, and this is a Y equals fx, the function. So if C is between A and B, if I say C is here, okay, if C is here, but not necessary, okay, so in our property C not necessary to do B between A and B. This is easy to look at. If C is between A and B, this time look at A to C is the area, this, right? C to B is the area of this. If we add these two areas, what we can get? We can get the total area of the curve under the total area of under the curve and between A and B. But remember, okay, remember this. C is not needed, okay, definitely is not needed between A and B. And if C is not between A and B, you also can prove. So you can go into you can go into prove by yourself. It's not, okay, definitely not needed, okay, to between A and B. How about the second? So the second is this. F function is a function. This is a linear combination. A linear combination to integration is the linear combination of the two integral, the two integrals. So we call the linear property. Okay, so linear property. So I will going to prove the second one here. Okay, the second one. So I will prove the second. So we need to look at. So I directly go from the left. Okay, from the left is like this A to B. Linear combination. Linear property is a very, very important property for many operations. So in the future you will learn. Okay, if you go to linear algebra, so you have this is the common properties, and plus, and d times gx, and dx. Okay. So we look at the first. What are we going to do? This is a function. This is another function. We can use the sum rule, right? So this is exactly the sum rule. The sum rule we showed before. So use the sum rule. What we can get? We can get this from A to B. C times fx dx. The first part plus the second part A to B. D times gx and dx, and these two have the same pattern. And now I will going to show you, and this is what this is a linear combination. We call it scalar multiply, right? Scalar multiply, we can do this. This scalar number can factor out, okay, can factor out a C. Why? So I have to show this. Y as this, okay, I will put it here to show you something. Okay, what it does factor out. What do we have? We have C times the integral A to B, fx and dx. Okay, see, C we can take out. Why this is correct? Okay, why this? from here and this. So remember we called we simply give a name. This is a scalar multiplication, right? Scalar multiplication. Someone will say this is a scalar. Okay, it's a scalar multiplication rule. Multiplication rule. Why? So this one y equals this. I'm going to show you here. Because a b c times f x dx. I'm going to use the limited definition. It is m approaching infinity, right? And then sigma I from 1 to n, and the c times f x I, the integral function, and then times that x, the definition. And then remember this. So this is a constant number, does not depend on I. So this c we can factor it out, right? This is what the summation rule is. We use summation rule. Summation rule we used before, and then c. So c can put here, and also we c can put out. Okay, again, so we can also put out directly, put to here, and then again put out of the limit. That's a scalar multiplication, the limit rule. Right? So finally, what do we have? We have a c times the limit m approaching infinity sigma I from 1 to m f x I delta x. See, this is the Riemann sum. This is the integral, right? So we're going to see is c times the integral from, definitely is from a to b f x dx. Okay, done. So we can see this is scalar multiplication rule is correct. Means that the constant number can take out. So the same, this is a constant number, right? So this is also constant number. Can factor out again. And then we'll put that together is plus d times the integral from a to b gx and dx. Okay? Together. It's just the results. Tell you the scalar multiplication can take out. Scalar number can take out. And these are two properties we're going to use. And look at it. The first example. Two examples I was going to show. And which rule are we going to use? And they give you one integral, another integral. We have the third integral. And this one we can see 4 to a is limit is a link to 2 to a and 2 to 4, right? 2, 4, 8, 3 number are linked together. So what? This looks like the addition rule we can use. We're going to do, should we do this? It's better I draw graph. I draw graph is understand much better. I draw a simple graph. Okay. And if I say the function is this, y equals fx. This is 2. And this is 8. So 4 is between, right? I say 4 is here. 4 is here. So look at it. And what are we going to find? What are we going to find is this area under the curve, 4 to 8. But 4 to 8, you know, what do we know? 2 to 8, the big one. 2 to 4, the small one. See, we can use what? We can use definitely use the addition rule. Okay, so if I write here is the addition rule we can use. Remember addition property, right? So addition property is this: integral 2 to 4 fx dx plus 4 to 8 fx dx. This part, but this part is the total part, equals the total is 2 to 8 fx dx, right? See, and the from the information 2 to 8 we know, 2 to 8 we know, 2 to 4 we know, 2 to 4 we know, and the question is 4 to 8. Definitely, this is the question, right? You know how to solve. Just solve this. So I put it here is 4 to 8 should be what? 4 to 8 fx dx should be equal this one minus that one. Okay, 2 to 8 fx dx minus that one, 2 to 4 fx dx. We know this, plug in. This is how many? 2 to 8, 7.3. This is a 5.9. Do calculation, you get a 1.4, right? Okay, that's all for this question. Use the addition rule, easy to get. One more question. Look at this question. If we know 0 to 9 f, we know 0 to 9 g. This is two function. Okay, the same interval for integration, right? The same interval to integrate. So what we need to do is find see, there's a pickle. What do we know? This we call the linear combination, right? This is a linear combination of two functions f and g. Linear combination. That means what? We can use the linear property, right? So we can use the linear property to do. You know what is the linear property? Linear property means you can separate, and the 2 can factor out, 3 can factor out. We just have. Okay. Or I just show you. See this, right? The linear combination. So we can separate it into 2 linear combination. The linear combination of the integral function can separate it into 2 linear combination of the integral. This we call the linear property. So we're going to use the linear property. I think now it should be easy, right? So 0 to 9, what we need to do is this linear combination, and then the linear property, we can do this 2 times 0 to 9 fx integral plus 3 integral 0 to 9 gx dx, right? Okay, this we call the linear property. So put here linear property. And the first one 37, the second one 16, all knows. So plug in 2 times 37, 3 times 16. Okay, do calculation. What we get is 122. I get this number. Yep, that's all. Thank you.